Hi everyone, for this experiment we will be explaining and demonstrating the effects of salt on ice. We will be doing this by having two setups, one with salt and another without salt. Ingredients you will need are whipping cream, vanilla essence, sugar, ice, salt, and containers of two different sizes. First, we put about 50 ml of whipping cream, 1 teaspoon of vanilla essence, and now 3 teaspoons of sugar into a smaller container. We stirred the mixture with a spoon and poured the mixture into another container. Then after that, seal the container tightly. We then place the container inside a larger container. We filled the larger container with ice. Then we sprinkled the ice with salt. Repeat this experiment again without adding salt to the ice. Label the two setups and leave them for about an hour, shaking occasionally in between. Next, we will explain the processes behind why we shake the cream.
When the cream is being shaken or whipped, air bubbles are introduced into the mixture. After being shaken for a while, the phospholipid membrane of the fat globules in the cream are broken down by the force of the container being shaken. This exposes the hydrophobic parts of the triglycerides to water, which causes the triglycerides to clump together. Some triglycerides align themselves with pockets of air, creating a network of fat globules surrounding the air bubbles. This forms a stable and slightly solid structure, which causes the cream to become a light and airy mass. To explain why we put salt on ice, we will first explain how ice is formed.
When the temperature lowers, the H2O molecules in pure water slow down. Eventually, the water molecules move so slowly that they no longer escape the intermolecular forces of attraction between the molecules. As a result of these forces, a lattice of water molecules form and water becomes ice.
During this phase change, water molecules enter and leave the solid at the same rate. Salt disrupts this equilibrium by being present as it does not bond with the water molecules. With the addition of salt, less water molecules are present at the interface between liquid and solid. In other words, salt particles block the water molecules from re-entering the solid phase, so more water molecules are leaving and less are entering the solid.
When the temperature lowers even further, the water molecules leaving the solid phase will slow down to match the rate at which the water molecules enter the lattice. When the rate at which the water leaves the solid balances the rate at which the water molecules enter, a new freezing point is established. Ice cream is then formed when the temperature of the cream is lowered due to the ice absorbing the heat from the cream. The cream then solidifies further and becomes thicker to form ice cream. In conclusion, the cream in the container with salt on ice is more solid than the cream without salt on ice. This is because the ice with salt has a lower freezing point, causing it to absorb more heat from the cream and for it to solidify faster than the ice without salt. As seen in the video, the cream put in the container with salt is much thicker compared to the cream without salt.